For lesson 1, so simplifying rational expressions, part 1. So in previous courses we have learned that the quotient of two integers, 4/7, is a rational number. All that means is, as we talk about rational numbers, rational numbers are anything you put in a fraction. Okay, so then based off of today's lesson, rational expressions is an expression in a fraction. Okay, x plus 7 is an expression. It has a variable. Okay, x plus 8 is an expression. So that's why this right here would be called a rational expression. Okay, that's just kind of basic vocab. Okay, a single variable rational expression is an algebraic fraction in one variable in which the numerator and denominator are both polynomials. Okay, so x minus 3 over x squared plus 1, those still use the same x, so that's still a rational expression because it's using the one variable. We will do mixed variables later, but we'll get to that later. And then 7 over 2y plus 5 is another example. Okay, it just has just y's. Okay, this unit will also learn how to add, subtract, multiply, and divide rational expressions. So we're just going to do pretty much all the fraction rules, adding, subtracting, that's common denominator stuff, multiplying, dividing, that's just right there with the fractions, a little bit easier, but you're going to get harder expressions. And so yeah, those kind of the main things we're going to be doing is the 4 fraction rules. Okay. Okay, the key to success in operating with rational expressions, it lies in your ability to factor polynomials. So it's going to come back to your ability to factor. So when you're doing these, you want to make sure, and this might be something you want to highlight just as a review, but these should not be forgotten. Okay, greatest common factor, GCF, difference of squares, don't forget those patterns. Okay, and that's pretty good timing because that's a whole unit we did. You got a midterm coming up, so if you did forget your factoring stuff, this is a good time to kind of go over it again. Okay, inspection, which is the easier factoring trinomials, decomp takes a little bit longer, and then the grouping if you have maybe a set of 4. Okay, any questions on the review of that? I guess probably pretty good. You guys had a good factoring test, so all right. Let's get to our first investigation here. Okay, so consider the rational expressions 2x plus 2 over x squared plus 3x plus 2 and 2 over x plus 2. Okay, so what we're going to do is we're going to plug in these x's and see what we get. Okay, for both of them. So if I plug in a 0 into here, what's the top going to be? 2. What's the bottom going to be? Right, it's going to be 2 over 2, which is 1, correct? How about if I do it on the second one? I'm going to get 2 over 2, again, which is 1. Okay. All right, now, if I put a 1 in, 2 times 1 is 2, plus 2 is 4, so top is 4. 1 squared is 1, plus 3 times 1 is 3, which is 4, plus 2 is 6. 4 over 6 reduces to 2/3. You'll see the one on the right. 1 plus 2 is 3. I get 2/3. Okay, you just keep plugging these in. 2 times 2 is 4, plus 2 is 6. At the bottom, 2 squared is 4, plus 2 times 3 is 6. 4 plus 6 plus 2 is 12. Gives me 1/2. And that gives me 2 over 4, which is 1/2. So we're seeing a connection here. Okay, they keep outputting the same thing when you simplify. Putting in a 3, 2 times 3 is 6, plus 2 is 8 this time. 3 squared, 9, plus 9, plus 2 is 20. And 8 over 20 reduces to 2 over 5. Oh, no, that's true. No, that's right, 2 over 5. It's wrong on my notes. Okay, 2 over 5, and the last one would be also 2 over 5. 3 plus 2. All right, last one, 10 over, 4 squared, 16, plus 12 is 28, plus 2 is 30. 10 over 30 is 1/3. and then I get 2 over 6, which is 1/3. Okay, what can we say about the values in the rational expression for both of them? When we replace them, we can say they're all the same. Okay, so they end up being the same. Okay, and we're going to go ahead and show you why. And this is kind of what we're doing with rational expressions. Why are they the same? Okay, the expressions 2x plus 2 over x squared plus 3x plus 2 and 2 over x plus 2 are known as equivalent forms. So what that means is this simplifies to this. That's why they came with the same outputs. Okay, so how can we figure that out? Well, we can factor these two. I can GC at the top and I can inspection the bottom. This is where the factoring comes into play. So if you look, they pull the 2 out. That gives you x plus 1. What's the bottom factor to? Factors of 2, that to 3. Hold on, you can do that. Wake up. Yeah, just x plus 2, x plus 1. Okay? Now, when you're multiplying, okay, not adding and subtracting, but this right here is a product. This right here is a product. Okay, I have two products. Whenever you have products, you can cancel. And that's what happens. That cancels and gives us 2 over x plus 2, which was the equivalent form they gave us. That's why they end up being the same. Okay, does that make sense? So they were equivalent forms because the x plus 1's canceled off. Now they can cancel just like if I had a 2x squared over a 3x, I can cancel an x because they're products. These right here are products. If it's 2 plus x plus 1, we couldn't cancel them. You can't cancel addition, subtraction, or multiplication. That's why factoring helps us, because factoring gives us products. Okay? Any questions there? So this, in simplest form, is that. When you go ahead and simplify and cancel. Okay? Do not do this. Some people think they can cancel this off, but you can't, because why? That's a plus there. It's not a product. You can't cancel that off like that. It's not going to work. Okay? All right. All right, let's get into permissible values now. Okay, so off the same table we just did, we're going to plug in 0, -1, -2, and -3. Okay, if I plug in 0, again, we know what that is. It's 2 over 2, 1, 2 over 2, 1. Now, if I put a -1 in, what happens with -1? Well, the top, -2 plus 2 is what? What's negative? Yeah, 0. I have -1 squared is 1, plus a -3 plus 2. I get 0 again. Okay, I'm going to call this intermediate, which I'll explain what that means in a second. Let's do it on the simplified one. 2 over x plus 2, and if I put -1 in, that just gives me 2 over 1, which is 2. Does anyone take a guess why -1 gave you 0 over 0 based on what we just did in the previous page? Why do you think that became 0 over 0? Looking at that previous breakdown we just did. What did we cancel? What did we cancel on this earlier? When we factored this out, what canceled? The products of what? What was that product? X plus 1. And what's the 0 to x plus 1? A -1. You see what I'm saying? So that was, remember, when we factored this out, just a refresher here, it was this. If I put a -1 in, that makes this 0 and this 0, which makes that 0 and this 0. So that's what this is telling you. Okay, the thing we canceled, 0 over 0, it comes from that -1. Okay, now let's look at -2. If I do -2, I'm going to get -4, I'm going to get -2 on top. Okay, and I'm going to get 4 Negative 6 plus 2. I'm going to get 0 on bottom. What do we know about stuff over 0? Yeah, undefined. It's not possible. And why is that? Well, if we go and we look at it simplified, what's left on these? The thing that's left is the plus 2. Okay. Okay, so negative 3 is not a problem. Negative 3 ends up being negative 6 plus 2 is negative 4 over 2, which is negative 2. And then I get 2 over negative 1, which is negative 2. Okay, so 0 and negative 3 are good. Negative 1 and negative 2 have some issues. Okay, so when I come down here, it says, for which values of x is expression not defined? So any box here that's over 0 makes it undefined. So it's technically undefined here and here. Those are two undefined values, because those will give me at 1.0 on the bottom. Even after we simplify, because if they give me this, if I put in negative 1, I'm still going to get undefined. Okay, if I just had this, then the only one would be this one. But we're talking about this and this, so it's both of them. Okay, so we're going to put negative 2 and negative 1 are the values in which x is undefined. Okay, and that's for this guy. Okay, and then for which values is it undefined for 2 over x plus 2? It's just the negative 2. So this right here would be just the negative 2 on part C. Okay, I'm going to move it up here, so you're going to lose a table. So what causes things to be undefined? This should be automatic. What causes it to be undefined? 0 on the bottom. Okay, simple enough. Okay, and it says values of the variable which result in the value of a rational expression not being defined are called non-permissible values. So anytime you get a 0 on the bottom, that makes it non-permissible. Okay, so you have to pay attention to when you get what. Like if they're asking what's the non-permissible of this, this one has two non-permissibles, negative 2 and negative 1. If it's asking this one, it's just negative 2. Okay, what makes 0 on the bottom? Because negative 1 still gives you 0 on the bottom of this guy. Even if you cancel it, it's still how you get, long story short, you get your non-permissibles from the original equation they give you before you simplify. Okay? Does that make sense? So non-permissibles, again, what causes 0 on the bottom? Okay, all right. And the non-permissibles are your restrictions. So the restrictions is just from our warm-up, the domain. So you would just say x can be all real numbers except for the non-permissible values. So for this guy right here, x can be all real numbers except negative 2 and negative 1. For this one right here, x can be all real numbers except negative 2. That's how you'd state the non-permissible values and the restrictions. All right, we're just going to do a couple of examples now, and that's going to be it. All right, so let's actually see some problems here. All right, so all we have here, example 1. Okay, so express in simplest form, state the non-permissible values of the variable. So what we need to understand is, right here, I can simplify this, but is it like... is this can I factor this at all? The top or bottom, can I factor them? No, they're monomials. They're singles, right? So you can't really factor anything. It's not a trinomial. It's not a binomial. So what is my non-permissible? You can see this one right now. Not 2, because 2 times 2 is 4. What's that? Exactly. X can't be 0. So my non-permissible, NP, is x equals 0. Or domain, x is all real numbers except 0. however you want to write it. Non-permissible is 0, it just can't be 0. Okay, as you get going, I'm fine if you just say non-permissible x can't be 0. That's fine. You don't have to put the real numbers every time. It's fine, because it's not technically asking for domains. It's a little bit more information than you need. But we still can simplify. And to simplify this, 12 divided by 2 is 6. X2 over x is x. So that's the simplified version. Okay, so Carson, give me one of the two non-permissibles on B. So non-permissible, A can't be. -1. Okay, good. And Jordan, what's the other one? Nope. Bottom. Right, -7. You only get your non-permissibles from the bottom, okay? So -1 and -7, if you plug those in, you put your calculator, it's going to say, can't do. It's going to say, it's going to take you to error, okay? Here, you can see -1 makes a 0, -7 makes a 0 on the bottom. Okay, now is there anything I could simplify here? Is there anything we can cancel? We can cancel the A plus 1. It's good. So I can go cancel, cancel. So your simplified expression is A minus 6 over A plus 7. So again, the steps that we're doing right now, we're simplifying rational expressions and stating the non-permissibles. We're getting the non-permissibles from the factored form in the beginning before we cancel. So my non-permissibles came from those two right here before we canceled. Even though we canceled the plus 1, it's still a non-permissible. Okay? And then our simplified version is right here. So now the next two we actually have to factor a little bit. The top I can't factor, but the bottom I can. So let's see, Connor, what are factors of 20 that are 1 apart? What's that? 5 and 4, good. So it's going to be y plus 4, y minus 5. So then Nick, off of what he just factored, this is where it's coming all together. What's my non-permissibles, Nick? Good. Y can't be -4 and +5. Does that make sense? Everybody good with that? So then, Jake, can I cancel anything? And if I cancel y plus 4, what's on top? A 1. Very good. So here we go. Y minus 5. 1 over y minus 5 is your simplified equation. Okay? So our non-permissibles come from the bottom, -4 and 5. We cancel the y plus 4s, and we get 1 over y minus 5. Okay, good. Bethan, can you factor the top and bottom for D, please? Yeah. All right, find it? Okay. Okay, good. So then, Evan, what's my non-permissibles? Good. X cannot be -7, 7. And Wes, how can I fully simplify? Good. There you go. Okay, is there any questions? That's day 1, not too bad. Okay, obviously it will get harder. Okay, and I'll go ahead and print you up a homework sheet right now. So that's it for that. So